Hi, welcome back. This is Professor Ridge, and today's lesson on section 5.5, factoring perfect squares, and perfect square trinomials, and difference of two squares, or just difference of squares. Okay, so this is basically the special factors that we did, or special products we did in 5.2, where if you square a binomial, and I said that this is something we do a lot, so you memorize this pattern, a squared plus 2ab plus b squared. Now we just write it backwards, and factoring is going in reverse. So this is a perfect square trinomial. Okay, and you get a square of a binomial. So the way you factor it, first you got to recognize that it fits the pattern. So basically here's what I do. So you got to do factor x squared plus 6x plus 9. What you do is you first look at those two things. Those are perfect square. That's a perfect square, perfect square. Now check. So this is your A, that's your B. Now check that the middle term sorry, 2AB. So 2 times x times 3. If it is, then you're done. It's just going to be x plus 3 squared. And so is 2 times x times 3 equal to the middle term? And the answer is yes. So the answer to factor that is x plus 3. Now, most people say, well, that's, silly. I could do that. What are factors doing the way I just taught you? What are factors of 9 that add to 6? Well, 3 and 3. And then the bigger one, well, there's no bigger one. But we're in luck to get a positive 9. These both have to be the same as b, so they're both positive. And that's the same thing as x plus 3 squared. So really it's not a big deal, right? But then it is very helpful because if I ask you to factor, say 25x squared plus, I'm going to leave the middle blank and ask you, what should that middle term to make b to make this a perfect square? So if you look at the square root of the first term will be 5x. The square root of the last term will be 4. And since that middle term is plus, that will be plus. Now check. Middle term needs to be 2 times 5x times 4, which equals, see, 10, 40x. So if the middle term is 40x, then you're done. If it's not 40x, then you got to do the Ridge method on this one. Factors of 400 that add to whatever that middle term is. Okay? So that's how you recognize it. You got to see that the first and last term are perfect squares. You square root them. So 5x and 4. You multiply them together, that's 20x, and then double it to get 40x, and see if that's the middle term. If it is, then you're in business, you're done, you go to the next problem. If it's not, you erase it and do the Ridge method. Okay, so factor 100x squared plus, say, 9y squared. So again, if our middle term would be 60xy, we're in business. So we take the square root of the first term, 10x, plus square root of the last term, 3y, we're going to check to see that 10x times 3y times 2 equals the middle term. And if it does, so that's 20, 60, xy, check, then you're done. If not, you cross it out or erase it and do the ridge method. Okay? So that's a great method to know. It saves you a lot of time for perfect squares that are, if the first term's not a 1. First term's 1, no big deal, right? Factors like the one I just did up there, factors 9, they add to 6. Okay? All right. Now, let's go to difference of squares, next page. So again, in 5.2, we did this product of a sum and difference. And when we multiplied it out, the middle terms canceled out, and we were left with just a difference of two squares, a squared minus b squared. So you square the first term minus square the second term. So now factoring, remember, is the reverse of multiplying. So we should be able to recognize if we have two squares, then that was from the product of the sum and difference. So you square root the first term, write it twice, and then square root the last term, write it twice, and do plus minus. And that's all there is to it. So factor, say 10, or we have to be 100, x squared minus 49. So that's a square. This one's a square. So the answer is going to be 10x plus 7, 10x minus 7. And you're done. You should be, I refer to these as my friends, right? They come up a lot. They're super easy to do, so you got to recognize them like you would recognize your friend. So if I had 49 x squared y to the fourth minus 25 w squared. Okay, the first one's a square, so 7xy squared plus 5w, and then write it again, minus 5w. And it's really easy, so I don't have to think real hard. (64) x squared minus 100 y squared. Now this one, again, you always factor out common factors first. So what divides out of both of these? So even though they're both squares and I can do it, you may forget to factor out the common factor. So, you just want to get in the habit of look for common factors first. So you divide 4 out of both of those. Now if you didn't, if you just factor as difference of squares, if I just went 8x plus 10y, 8x minus 10y, now there's nothing wrong with that except you're not done, and you wouldn't get credit. I'd mark that problem wrong because you're not done. So you could do that, but then you got to recognize, you can factor this more, and what comes out of that one? A 2. So that gets you the 4x plus 5y. And what comes out of this one? 2. So that's 4x minus 5y. And then you bring this 2 out in front. So 2 times 2 out in front is 4. 4x plus 5y. 4x minus 5y. Okay? So it's fine as long as you catch it at some point and your final answer is completely factored. But it's always a good idea that you just get in the habit of look for common factors first, and then you won't have that problem of forgetting to do it later. But even when you do it first, you still need to look and you factor more. All right? Okay, let's try another one. Let's try 16x to the fourth minus y to the fourth. So again, those are both perfect squares. There's no common factors, so 4x squared plus y squared, and then 4x squared minus y squared. And then you notice that oh, this is the difference of squares again, so I can factor that one more time. Now you can't, no, you can't factor other than GCS, but you can't factor a sum of squares. Okay, you're done. That's prime. But a difference squares we can do. So that's 2x plus y and 2x minus y. And that's another reason I do the plus one first, and then the minus one, and then I look at the minus one and see if I can factor that more, which in this case I could. And now I'm done. Okay, so you want to make sure you factor completely. Alright, so remember when I was talking about factor by grouping, and sometimes you can factor it as group of 3 and group of 1. So this is the special case where that happens. You got 4 terms. There's no common factors. But what you got to do is you got to recognize that, okay, this is a perfect square, trinomial. This is x plus y squared. And then that's 9 is 3 squared. So again, I view this x plus y in parentheses as one number. So that's no different than if I asked you to factor w squared minus 9, and you're going to tell me w plus 3, w minus 3. So we're going to look at that x plus y like the w over here. So it's going to be x plus y, that's my w, plus 3, and then x plus y minus 3. So that's how you would factor that one. Okay, so you can do a factor by grouping with 3 and 1, and if it makes a difference of squares. So if 3 terms is a perfect square trinomial, you want to look for that difference of squares. Alright, let's do one more of those. So let's see here. Number 76 is p squared q minus 25q plus 3p squared minus 75. Now this one doesn't look like I got a perfect trinomial difference of squares. So let's try group of 2 and a group of 2. So from the first group I can take out a q. And I get p squared minus 25. And then the second group I can take out 3 and get p squared minus 25. Now let's move it over here where I have room. Okay, so the p squared minus 25 and the parentheses match. So I factor the parentheses out. If I think of those going away, what's left over? Q minus 3. Alright, and then you get asked, are you done? And the answer is no. This is the difference of squares. So I can do that. P plus 5, P minus 5, and then bring down the Q minus 3. Alright, now I'm done. Okay, so that concludes our lesson for 5.5. Go to my math lab, complete your exercises there, and I'll see you next time.